Okay, so in theory, you should be able to see this. So I will do a couple of them together for you really quick. With elimination, what you are looking for, you want two of your variables, you want their coefficients to be able to cancel each other out. So in this case, you have a positive 1y and a negative 1y. So when you're adding down, they will cancel out, which is exactly what you want. So in purple, I will add straight down. X plus an x is a 2x. The y and the negative y will cancel each other out. And 8 plus 4 gives you 12. You can keep solving like normal, divide by 2 so that you can get x by itself. X equals 6. When you get to this point, you now know what x is, but your solution needs to be an ordered pair. So you now know your x is 6, but we don't know what y is. So we're going to take our x is 6 and plug it into one of the two equations that we started with. Personally, the top one is my favorite just because...
All custodians, please report to the science wing downstairs.
Sorry. The top one is positive, so that'll be easier to plug into. So we have whatever x was plus y equals 8. In this case, x was 6. So we can work like normal. There's nothing in those parentheses to deal with, so I'm just going to bring it out. I want to get y by itself. I will subtract 6 from both sides to do that, which tells me that y equals 2. So my ordered pair solution is 6, 2. I have two more. One that will cancel nicely we'll do next, and then I'll backtrack for the one that doesn't cancel as nicely. Once again, you can look at your y's and you will see that one is positive and one is negative. So those are perfect. They will cancel out when we add down. So adding straight down, 2x plus 2x is 4x. My y's will cancel, and I will get 92. Hang on, I thought somebody was coming. I guess not. So then I can go about my life as normal, divide by 4 on both sides, where x gives me 23. Same thing, I only know my x so far, so I can't speak for my whole solution, but I know that the x is 23. So I'm going to plug that in. The bottom one this time doesn't have any negatives, so in my opinion, that's a little friendlier to work with. So we will plug in our 23. Let's work in red this time, because why not? 2 times 23 is 46 plus y equals 60. To get y by itself, I need to subtract the 46 from both sides, which leaves me with y is equal to 14. So my solution, as a point, the x is equal to 23, the y is equal to 14. Sometimes you will see that they don't necessarily cancel as nicely. Nothing here is going to explicitly cancel, but if I look at my x's, I can see that they have the same coefficient. They both have the coefficient of 3, which is perfect, because if I make one of them negative, they will be able to cancel out. So what I'm going to do is multiply this entire bottom equation by -1. If I multiply that entire bottom equation by -1, I'll get -3x plus 0.4y equals a -4. It'll just shift my equation so that everything's sign flips. I'm going to just bring the other one down so that they're still nicely nestled on top of each other. And we will add straight down again in red. -3x plus a 3x will cancel. 0.4 and 0.2 make 0.6y. And negative 4 plus 7 gives us a 3. 3, when I divide it by 0.6, gives me y equals 5. And I want to plug that back in to one of my equations up at the top. The top one, like we mentioned earlier, this top one up here, I'll put the red star next to it, doesn't have negatives in it. So that looks like the friendliest choice to me. So we have 3x plus 0.2, whatever y was, equals 7. And that whatever y was 5. So in purple, we can solve like normal. 0.2 times, 0.2 times 5 is 1, which brings us back to algebra 1 roots. We subtract the 1 from both sides. 3x is equal to 6, which makes x equal to 2. And my solution is 2, 5. Hopefully that helps, and just let me know so that I can help you out.